Hello and welcome to WEEP instructional videos. My name is Stephanie and today we'll be talking about key assumptions and unit conversions within them. Key assumptions provide a way to add structured data to your model. You can reference them in expressions elsewhere in WEEP, and they can act as variables for all your major modeling assumptions, especially those that will change from scenario to scenario. They'll help organize and highlight the most important parts of your model, help ensure that consistent assumptions are used throughout your model, and make it convenient to view and edit them. You may create a multi-level hierarchical structure for your key assumptions, grouping together related concepts. Key assumptions can also be used in the Scenario Explorer. To see how, watch the existing Scenario Explorer video. In front of you, you can see an example model of the Murray-Darling Basin in Australia. This is not a real model, but we can see some characteristics that we're likely to see in other models. We see that there are 5 different demands for the 5 different territories in this area. So we've got the Australian Capital Territory over here, Victoria demand, this is South Australia, New South Wales, and Queensland. We also have 2 rivers, the Darling and the Murray, that are both flowing down towards the center of Australia, and we have a single gauge over here. Now, going into the data view, we can see that each of these demands is divided into 3 different types of populations: Indigenous, non-Indigenous, and unknown. Now, between our 5 different demand sites and our 3 different types of population, that's potentially 15 different sets of data that we need to enter. But if we're thinking about key assumptions, there might be some similarities. In this case, we're going to say that there are similarities across water use rates. So let's look at Queensland demand and look at the water use rates. So we can see that it varies, again, by Indigenous, non-Indigenous, and unknown cubic meters per person.
And remember to note here that we're referring to annual water use rate.
Alright, so if I assume that these different populations are going to have similar water use rates even within the different territories, I can make a key assumption, and that's exactly what I've done up here. And if you want instructions for how to do this, you can look at the WEEP tutorial. There's a module about making key assumptions. So I'm going to open up my water use key assumption that I've built, and I'll look at my data all together. And I'll say that I have data about liters per capita per day. So for my unit, I'll put down liters, which is a volume. And I'll say that the Indigenous population I know uses 100 liters per capita per day. But we saw a moment ago that the water use rate as it's plugged into WEEP is annual, so I'm going to have to multiply this daily rate by 365 to make it an annual rate. And I'll say that the non-Indigenous population use 150 liters per capita per day, and the unknown is somewhere in between. Now let's look at what that looks like. Well, first we have to actually connect the water use rate to the key assumption. And again, this is demoed in the WEEP tutorial, but I'll show how to do it here. So we'll click on the box, the arrow appears. Let's open up our expression builder, make sure we're on the branches tab, and then open up key assumptions, water use, and the first one I'll pull down is Indigenous, and you can see that it writes out the expression for you. And I can do that for the others as well. Branches, key assumptions, water use, non-Indigenous. And I can also, move this, show you that I can copy and paste. And then I could type in, for this last one, unknown, and it will populate correctly. Now notice that we're looking at the unit liters still. And so this is populated with values of 36,500. So that's the number of liters. It's not the number of cubic meters. If I want WEEP to do that conversion, I have to tell it to. So I'll go in here and I'll type meters cubed, and then it will do the conversion for me. There. I also want to demonstrate the Elaboration tab. So as soon as you've plugged in your key assumptions, you can go to this Elaboration tab and it will tell you where this data came from and what it says in that key assumption data. So here I'll click here and it'll take me right back to that key assumption that I edited. I can also see all of the other demand sites that are using that same key assumption. So for this example, I've plugged them into the other 5 territories as well, so that they're all reading the same values for population demands of Indigenous, non-Indigenous, and unknown populations. Returning to Queensland, we edited the input data to make it do those unit conversions to cubic meters. Another option, if I had wanted to do it this way, I could have gone into my general menu and said units, and gone into demand, and we see that there's a default water use rate that's cubic meters. If I really wanted to change the default water use rate to liters, I could do it here. So we could open up the menu and liters is the first option. However, this would only change the water use rate unit for new branches that you build. So we see that if we go back to our old branch, it's still going to be listed as cubic meters. So only new branches will show the liter unit there as the default. I can always change it right here by opening up the menu and choosing liters, but now that I've switched it to cubic meters, I'll just leave it. Next up, let's talk about using percentages in key assumptions. This example is shamelessly stolen from the WEEP tutorial scenarios module. And what we want to know is, since we have already plugged in our annual activity level, which is the population starting in 2006, we want to know how this changes over time in my reference scenario from 2007 to 2020. So going into the population growth key assumption, I can plug in population growth rates for each of my different territories. Again, these numbers are not meant to represent actual data. Note that because Queensland is using annual activity level, all of these population growth rates need to be annual population growth rates. So if you have a growth rate between, say, 1999 and 2006, you have to convert it to an annual population growth rate for the period that you're interested in. An advantage to using the key assumptions to model population growth rate is that it's very easy to create a new scenario where you could just change the key assumptions, say to model a higher population growth rate, and then those changes would populate outwards into the territories that you've already connected the key assumptions to. And then you can make your comparisons between the two scenarios without having to change a lot of data. And you can see here that I've plugged in my unit as a percent. Interestingly, I didn't plug that into the unit column, rather the scale column. And that's because percent can be a type of unit, share, or saturation as well. Look those up in the tutorial if you have questions about them. But if it's just the unit by itself, then you can plug that in under scale, percent. And let's go into Queensland again and go into the reference scenario and imagine plugging in that data. So what I would do is open up my expression builder and go into my functions tab and go to growth and delete the data. And I want to say growth using that key assumption population growth rate that I plugged in. So I'll go back to branches, open up my key assumptions, population growth rate. I want to grab the population for Queensland and plug that in. And I'm going to plug in the same population growth rate for all the different populations because they're all in Queensland. So this emphasizes that you may group your data differently, whether it's by population type or whether by region, and you can do that in key assumptions. Now, thinking about unit conversions, let's take a look at how this data populated. It is my goal that if you see something like this, that you think, I have done something wrong. Because what we see is that in 2006, there were 9,000 people of Indigenous population living in Queensland. But by the end of my model in 2020,
the model shows 161 billion people.
So this is not correct. There's a unit conversion problem here. Let's go into this. And basically what WEEP is doing is it's reading that small percentage number and it's not reading it as a percent. So we have to divide it by 100. And that way we'll have something more reasonable. So I'm going to do that for all three. So just remember, as you're reading expressions into WEEP using percentages, you may have to divide by 100 so WEEP can read it correctly. And let's look at how that looks now. Much better. Let's look at the results for water demand. And we can see how the water demand is growing over time as a result of these population growths. Now the last thing that I'd like to show about key assumptions is how key assumptions can be used to help with land use parameter modeling. So here I've plugged in all of the different land use parameters that need to be filled out, and we can see that some of them need to be filled out even for different land use types. Now I could have different values for the two catchments that I'm looking at within the Murray River and the Darling River, but since I've gone ahead and put only one gauge in my system, maybe I can also assume that they have the same parameters for the different land use types. And if you're an Australian modeler, definitely object to this. This is an oversimplification. So let's look at the runoff resistance factor. So I've plugged in some values for it. If we look at the Elaboration tab, we can see that it's connected to our Darling River and our Murray River. So as I fill in this data, it will populate into those two river basins. And as I edit the data, it will also be edited in both of those river basins. There's an advantage to editing the data this way because then you only have to edit it in one place. Additionally, if you plan on doing any calibration using the PEST automatic calibration routine, all you have to do is plug in the key assumptions, and we will be able to perform the calibration from there. So here we've learned some different ways to organize your key assumptions and think about unit conversions. This has been a WEEP instructional video. Good luck with your models.